Hello everybody and welcome to the show. Today we'll be talking about high altitude cooking and how the gas laws affect them. The gas laws are Boyle's law, which states that the pressure and volume of a gas have an inverse relationship. When temperature is held constant, pressure goes up and volume goes down. Charles' law states that a given quantity of gas is held at a constant pressure. Its volume is directly proportional to the absolute temperature. When temperature goes up, volume goes up. Gay-Lussac's law states that the pressure of a sample of gas at constant volume is directly proportional to the temperature in Kelvin. As temperature goes up, pressure goes up. Finally, the combined gas law states that pressure times volume times temperature is held constant. Thank you, and welcome to. It's a beautiful day out today. It's a perfect time to talk about the history of cooking at high altitudes. So cooking at high altitudes has been a necessity of life throughout many cultures and mountain regions. At higher altitudes, air pressure is lower, so foods take longer to bake. Temperatures and bake times need to be increased. Therefore, many people all around the world use one of these pressure cookers. So in a pressure cooker, pressure is created initially by boiling liquids such as water or broth inside of a closed pressure cooker. The trapped steam increases the initial pressure and temperature. After use, the pressure is slowly released so the vessel can be safely opened. Many people have contributed to perfecting this art of pressure cooking, such as in 1679, the French physicist Denis Papin, better known for his studies on steam, invented the steam digester in an attempt to reduce the cooking time of food. His airtight cooker produced steam pressure to raise the water's boiling point, thus resulting in a much quicker cooking. In 1864, Gore Gutbrod started manufacturing pressure cookers made of tinned cast iron. Some other facts about pressure cooking is in 1919, Spain granted a patent for the pressure cooker to Jose Alix Martinez from Zargonza. Martinez named it the Express Cooking Pot. In 1924, the first pressure cooking pot recipe book was published. It was also written by Jose Alix, entitled 360 Recipes for Cooking with a Pressure Cooker. In 1938, Alfred Vischer presented his invention, the Flex Seal Speed Cooker, in New York City. This pressure cooker was the first one designed for home use, and its success led to competition among American and European manufacturers. At the 1939 New York World's Fair, National Presto Industries, which was then known as the National Pressure Cooker Company, introduced its own pressure cooker. Most pressure cookers have a cooking pressure setting between 0.8 and 1 bar above sea level. The sea level pressure is around 1.016 bar. So the pressure cooker operates at 1.816 to 2.16 bar. The standard cooking pressure of 15 psi above sea level pressure was determined by the United States Department of Agriculture in 1917. At this pressure, water boils at 121 degrees Celsius or 250 degrees Fahrenheit. Some examples of pressure cooking is that when cooking at 1 bar 15 psi above sea level pressure, approximate cooking times are 1 minute for shredded cabbage, 7 minutes for boiled potatoes, and 3 minutes for fresh green beans. If the pressure is released naturally after timing, cooking times are even shorter. Food cooks more quickly when cut into smaller pieces. A pressure cooker can also be used to compensate for lower atmospheric pressure at high elevations. The boiling point of water drops by approximately 1 degree Celsius every 294 meters of altitude, causing the boiling point of water to be significantly below the 100 degrees Celsius at standard pressure. So let's get to cooking. Currently we're at a very low altitude, so it's going to take a lot to boil some water. So let's start finding materials. Here's some wood. Now we need to get some tinder. Oh, there's some. Let's grab some of this. All right, let's get to making our fire. Let's get this fire started. Now that we have the fire going, now we need the food to cook. So let's find some. Wow, we just found the perfect specimen to eat. Look at these. They're wild platypus eggs. Oh no, it's coming. Now we have the fire and the eggs. Now we need the water to boil it in. So I just stumbled across this stream here, and we're gonna get some water. Perfect. We're gonna fill it up halfway, and we'll do that at high altitudes and low altitudes. This is the low altitude test. All right, let's boil the water now. As our water boils, we're going to talk about why it does at high and low altitudes. As you increase altitude, the density of the air becomes thinner, and this thinner or less dense air then exerts less pressure. So the higher the altitude, the less dense the air and pressure decreases, until in space, no air, no density, and no pressure. As you increase altitude, the external pressure on the water is decreased. Therefore, it will take less energy to break the water molecules free from their bonded energy. If it takes less energy, then it will take less heat. And this is the energy we are introducing. If less heat is required, then less temperature is required, then the water will boil at a lower temperature. This demonstrates Boyle's law in cooking. And the other law, which is the combined gas law, applies, because if we cook an egg at a lower pressure, the temperature and volume of the air increases, and use those same variables at sea level and plug in the appropriate variables into both sides, this will be equivalent, resulting in a properly cooked meal. All right, so now the water is boiling, as you can see. Got a little bit of wood in it, but that's okay. So now we're gonna throw our egg in. It was exactly 5 minutes and 30 seconds to get it to boil. Let's see how it does with boiling an egg. While our egg is cooking, let's talk a little bit about boiling water. Some more on cooking at high altitudes is that when air pressure is lower, foods take longer to bake. Temperatures and bake times may need to be increased. Liquids evaporate faster, so amounts of flour, sugar, and liquids may need to be changed to prevent batter that is too moist, dry, or gummy. Gases expand more, so doughs rise faster. I'll also include a chart at the end of this video that talks about baking and baking times, how you can cook at high altitudes versus low altitudes. It's very helpful if you are cooking at these high altitudes. So our egg is done cooking. Took exactly 4 minutes after we boiled that water. It might not look super appetizing, but it'll keep us alive. Let's take it out and see it. Alright, so the egg at the low altitudes is now done. Let's cool it off so we can eat it. So let's crack this thing open and see how we did. Alright, so we have our egg and we're going to crack it open now and see how we did. Yep, that's hard boiled alright. So let's test and see what the higher temperature cooked like. So I took a bit of a road trip over to the Andes Mountain. I'm at the peak right now, as you can see. Look how far down that river is down there. So we're at a very high altitude, so now we're going to try to boil some water and cook that egg and see how fast it takes us. Alright, now we're going to start our second fire so we can boil that water at high altitudes and cook that egg at the same. Alright, now the fire is going, we're going to boil some water. Alright, I descended to get the water. Now this is the same temperature water as before. I've already tested it and we are filling it up to the halfway line. Right there. Let's get to cooking. So, as you can see, the water boiled much faster. It only took 3.5 minutes to do that. So that just proves that at higher altitudes, water boils a lot faster. We're going to see if it's the same with the egg. Let's put it in. Let's test it. All right, our egg at the higher altitude is now done. Let's crack it open and see if it's cooked. Yep, that's hard boiled. All right, now this was much faster. Well, it took 2.5 minutes to boil this. You can see it's cooked. Let's try it. So you may ask, what do these tests mean? Well, it means the higher to the altitude you go, the faster it's going to boil. Therefore, the pressure decreases, so the time to cook decreases. All right. Thank you for joining us on this episode, and I hope you all enjoyed. So now let's gather the wood. As you can see, oh Jesus. So there's that. Extra credit?